but we are going to talk about systems with 3 variables in them. So when you do this, we're still using substitution and elimination, but that third variable is going to add a few steps to our problem. We're going to have to take 2 equations at a time and eliminate some stuff. So here is our first example. So x plus y minus z equals -1. 4x minus 3y plus 2z equals 16. And 2x minus 2y minus 3z equals 5. So what we need to do first is pick a variable to eliminate. Okay, it can be x, y, or z, but I try to look at, all of the equations and see if there's something that's obviously easier. It doesn't really matter at all. Pick a letter. What do you want to eliminate? X? Okay. So what we're going to do is take 2 equations at a time and eliminate the x. So for instance, let's start with the first 2 equations. If I just wanted to look at those 2. If I want to eliminate the x, what would I have to do? Okay, so the first one times -4. Add those together, my x's drop, so I have -7y plus 6z equals 20. Okay, I have to take the equation I have not used yet, so that's the third one, and I need to eliminate the x in it as well. So I have to take this third one and pair it with either the first or the second. Doesn't matter which one. Which one do you want me to use? Second one? So if I wanted to put the second and third together and eliminate x, what would I need to do? Okay, I'm going to take this last one times a -2 and put those 2 together. So we add those. 4x and -4x cancel. -3y plus 4y is just a y. Plus 8z equals 6. Now what we have are 2 equations, and they both have the same 2 variables, y and z. So this is kind of where our problems picked up last week. We started with a system with 2 equations, so we need to either do substitution or elimination here. Elimination. So what do you want to eliminate? The y. So I could take the second one times 7. Okay. So we're going to put these 2 together. I'm going to take this one times 7. So that's 7y plus 8z equals 42. This would be -7y plus 6z equals 20. So 14z equals 62.
Didn't you take the 8 times 17?
Oh, yeah. Did you guys catch my mistake? I did not multiply my 8. So this should be a 56z. When I distributed my 7, I failed to multiply that term. Okay, so then when I add those together, we get a 62z equals 62. That makes it a lot prettier. Divide by 62 and my z is 1. Okay, now we have to work backwards to find all the other variables. Once you get to this point, it should just be a matter of plugging things in. So I have my z. If I put that in here, y plus 8 times z. So y is negative 2. Now I need my x, so we can plug those back into one of the originals to get my x. So if I just plugged it into the first equation, it's x plus y, which was negative 2, minus z, which is 1.
Do you have a calculator?
Back one second. You're welcome. Okay. Then, when you write these, we have 3 variables, so it's like an ordered triplet. You just always go alphabetical order. So that would be x, y, z. So my x was 2, my y was negative 2, and my z is 1. Just like any of the others, you should be able to check this. It's just a matter of plugging them back into all of the original equations, and it should work out. Any questions there? Let's take a look at another one. Okay, if I'm looking at this and trying to pick out what variable to eliminate, do you see something that would save us some time? Z. The last equation doesn't have a z. So if you ever have that scenario, then eliminate that variable in the others. So I just need to take my first and second and eliminate z, which is pretty easy. I don't even have to multiply them by anything. When you add those together, you get 3x plus 2y equals 3. Okay, I need to put these 2 equations together. What do you want to do?
You're going to have to
Multiply by negative 1. So that gives me a negative 3x minus 2y equals negative 3. And the other one was 3x plus 2y equals 0. And you add those together, x and y cancel, so you get 0 equals negative 3. No solution, and what's the word we write with that? Inconsistent. Questions on that one? Let's look at this one. So that's 2 over x plus 1 over y equals 3 over 2. And 3 over x minus 1 over y equals 1. Any thoughts on what we could do here? Okay. So one option, if you don't like fractions, if you want to get them off the bottom, you can multiply by x and y. Like Kyle said, if you add these together, does the 1 over y cancel? So if you're not afraid of fractions, you can go ahead and do elimination as it is. So if I just added these, 2 over x plus 3 over x would be 5 over x. Positive 1 over y and negative 1 over y cancel. Equals 3 over 2 plus 1. So then we could cross multiply. Divide by 5. And x equals 2. Now we need to find our y. Plug that back in. So we would get, I put it into the first one. Okay, if you subtract over your 2 over 2, you just get a 1 over 2. Cross multiply and y equals 2. So my answer is the order pair 2, 2. I would like to do one more of these together, and then I think that'll probably be all I do for today, and I'll save my other examples for tomorrow when everybody's here. So let's say I gave you pick a variable. What do you want to eliminate? X? Okay. So let's take the first two equations to start. If I want to eliminate the x in those first two equations, what would you have to do? Top one times negative 3. So that would give me a negative 3x plus a 3y minus a 15z equals negative 6. Sorry. I don't know why I keep doing that today. How about positive 18 there? And we left the second equation alone. Okay, so when we add negative 3x and positive 3x cancel. 3y plus 3y is 6y. Negative 15 and negative 1 is negative 16z equals 28. So if you eliminate x the first time, you have to eliminate the x again. Okay? We have not used the third equation, so I have to put that with one of the other two and eliminate my x again. So which one do you want to put it with? Second one. So then we just need to take the bottom one times negative 3. 3x and negative 3x cancel. two equations with both a y and a z. So I have to put those together and eliminate something. What's the easy choice? Yeah. My y's will already cancel if I just put those two equations together. So 6y and negative 6y cancel. Negative 16 and negative 7 is negative 23z equals 23. Divide by negative 23 and you get negative 1. Now we just have to work backwards. So to find y, plug that into one of your equations with two variables. So if I just plugged it in there. 6y plus 16 equals 28. Subtract over my 16. Divide, and my y is 2. Now I need x, so take y and z and plug them into any of the originals. So if I just did the third one. You get x equals 1. So if you write them as a triplet, x, y, z, alphabetical